I'm David with EV World News. We're talking about electric vehicles, green energy, and the stock markets. And I'm back in the studio today with our founder and chief editor, Bill Moore, and a special guest from across the pond over in the United Kingdom, Dunstan Power, the director of Versinetic. How are you doing, Dunstan?
I'm very good, thank you. Yes, yeah.
So it's early evening, I gather, for you probably?
Yeah, it's
5:40.
26. Yeah,
Yep.
5:40. Yeah.
Nice. Well, we want to thank you for coming along. Do you want to tell us? So we did a little research on Versinetic, okay? But can you tell us exactly where you fit in the supply chain?
Sure. Yeah. So Versinetic creates electronics and software for the manufacture of EV chargers, basically. So we're basic experts at designing EV chargers. We don't sell EV chargers, so we're not. But we've got companies in the UK, in the US, in Europe, who use our technology to make their EV chargers. Whether it's we've got a set of modules that you can put together, put them in a box, and you've got a charger. Or some of our customers just license software from us. So effectively, we're like a EV charging design house expert who actually has a set of IP blocks that we own the intellectual property of.
Nice. So tell us, you went to college at Cambridge?
Yeah.
And you got an engineering degree?
Yeah. My background's basically I did engineering at Cambridge, as you said. It was general engineering. I went into electronics. I was a sort of a electronics hobbyist nerd at home, soldering things together, driving my parents mad, burning holes in the carpet, that sort of thing. Electrocuting myself, building a bass amp. I remember once, this sort of thing. So that was why I was interested in engineering. It was that whole putting stuff together, solving problems, and then I went into electronics design and worked in various areas, signal processing, professional audio stuff, things like that. But I ended up in the sort of 1990s in consultancy, and I've sort of been in it ever since. And then I set a company up with a colleague in 2008 called Bytesnap Design, which is still going. I'm still a director of that, and that's a consultancy business that designs all sorts of things: medical, industrial, automotive, all sorts of products. And we span Versinetic out as a business because we were getting so many inquiries around EV charging. It was such a hot area. So like 2018, we decided to develop our own EV charger technology. And really, the real concept of the company is, whilst there's obviously loads of companies making EV chargers, they're mostly addressing the same sort of market. They're mostly doing domestic wall box mounted chargers, but there's still a lot of chargers that don't fit that market, particularly in the public charging arena. And we recognized that some of the companies that were coming to us who wanted to get into charging just didn't have any expertise around it. And it's got more and more complicated as time's gone on. More and more government regulations for the power supply industry. The cars themselves got more sophisticated. So the sort of barrier to entry's got higher and higher for somebody who just says, oh, you know what, I'll create an EV charger. So we've got a bunch of talented engineers who know all about designing complicated electronic products and software for them. And we had developed the charger controllers for the London Olympics in 2012. Okay. So we had like history in it. So yeah, that's sort of birthed the company.
Wow, the London Olympics in 2012. That's hard to fathom. So how many chargers did they have set up for that?
They had 120 chargers, yes. So they had there's 3 sites they were on. They were at the Olympic Park. They were at Hyde Park, which is a big basically in the hotel district, expensive hotel district. Oh. And then they had the Millennium Dome as well. So they had 40 chargers at each one, and then they had a fleet of electric minis. And the electric minis were there to ferry. It wasn't so much athletes; it was like ferrying all these dignitaries around. Basically, right. They wanted to do electric vehicles. And so Transport for London had this spec for what they wanted the chargers to do, because they wanted to remain in after the Olympics. So they were actually legacy. And actually, the specs of those chargers was remarkably similar to the most up-to-date EV charging standards now. It's quite forward-looking. It allowed remote access, remote diagnostics, whitelisting of vehicles, metering of individual charges. All the stuff that a modern smart charger does. And the problem that the Olympic Authority had was that this spec was buried in the small print. GE won the electrical contract for the Olympics, to put all the lighting, and obviously that was hundreds of millions of pounds, or whatever. And buried it in the small print on page 520 or something. It said, "Oh, by the way, you've got to put 120 EV chargers in," and they had gone, "Oh yeah, we've got EV chargers." And effectively, it was 2023. It was actually quite late in 2023 when we were approached by a contractor who had been GE Johnson said, "Look, we've got to fulfill this, but our chargers don't in any way meet the spec. They were just dumb chargers." And these guys had the contract for actually putting the chargers in the ground, but they needed somebody to actually make them smart and to tick all these boxes to do all the smart element. And through lucky, the guy who had the contract, and we got the job of doing the smarts for it, and learned all that EV chargers back then, and we've carried on sort of building on that.
That's fascinating to think. I just couldn't imagine there would have been a demand for 120 EV chargers.
Yeah, I know.
13 years ago.
Well, yeah,
exactly.
and apart from the minis, the rest of those were Reva G Whizzes. Do you remember? You remember the G Whiz?
Well, yeah. You look back at the history; it's quite funny looking back at some of the cars from that era. Yeah. The tiny things. Yeah.
Yep.
Yeah.
Yep.
Yeah, but Bill is definitely a veteran. He's been EV world since 1998.
1998.
Nice.
Yeah.
Great. Love it.
So he's seen all the craziness that's gone on over the years and how it actually started becoming normalized in 2012.
So can we sort of get us up to speed here? There's a charge controller on my EV, right?
Yeah.
And so effectively, I could take I've got a box upstairs that's mounted on the wall, or used to have one that was just a thing about this big, a brick that I would plug in to charge my electric car. Where does the smart part of this? You're just moving electrons, right? Where does the smart part? Why is that important now?
That's a really great question, because an EV charger, a standard domestic EV charger rather than a DC charger, it's just a glorified switch, really. As you say, all it's really doing is it's a big switch that's just coming in and it's switching your mains in your house to the car, and the car itself is doing the smart bit of rectifying that and charging the batteries. Yeah. So why do we need the charger? Well, all the smart elements. Well, the problem with it is that if you're just living in a house, and you've got a charger on the wall, well, the first thing is, do you want some sort of authorization on that? So, like when you're away, your neighbor drives in, he charges his car, drives away.
Oh, okay.
So that's the first thing. Do you want some sort of authorization? Second thing is about safety. Probably actually the most important thing. So you want to make sure that you only make that cable live when everything's nicely plugged in at both ends. Nobody's sticking a finger in it or whatever. So there's the safety aspect. So a dumb charger looks after the safety aspect. And if you open one up, you've still got a micro in there. You've still got a whole load of components. There's another safety aspect. It might be detecting broken earth. It's detecting that the current going into the car is what it says it is. So the car will say, I want this amount of current. Now, the charger itself can't control the current. It's just connecting it to the mains. But what it can do is measure how much current the car is taking and make sure that it matches what it thinks it's taking. And otherwise, it's a fault condition. So there's a few of these sorts of, they can measure the temperature on the socket. That's another thing. So there's a bunch of fault conditions the dumb charger does. So that's a level of complexity. Then for the smart charger side of it, it really applies mostly in public charging. So if you've got a charger out on a lamppost or in the street, firstly, the authorization thing is really important. You want to know who it is who's charging. You basically want to get money from them. So you want to know who they are.
Yeah.
Have they got an account? Have they? So that's mostly done using a language called OCPP, which is Open Charge Point Protocol, which basically is a language that the chargers talk to cloud-based servers. And those cloud-based servers might be tied into some sort of credit card billing platform. So basically, you turn up, it says, oh, download this app or scan a QR code or whatever. And that your phone basically says, I'm John Smith and I want to charge my car. And it goes, yeah, you've got an account with us. And it basically, takes money off your credit card. And then it sends a signal over the air or down an Ethernet cable to the charger to say, right, this guy's authorized, off you go. But the guys who own the charge point operator might also want to do maintenance on them. So they might want to upload diagnostic information from the charger. They might want to do firmware updates. So that's downloading firmware. And it's really about them controlling their assets and knowing what they're doing. They might want to do load balancing. So this is quite a big topic now. So if you're when you've just got one charger here and there, it doesn't really matter. But of course, there's a lot more EVs on the street now. And the power companies get worried that everyone's going to come home from work in the evening, cold winter's evening, it's all dark. Everyone comes at home at 5:30, 6 o'clock, plugs their car in, turns it on, starts drawing 32 amps on their single phase power supply, and everyone in the street's doing it. And the grid just isn't designed to work like that, to cope with that. So again, the smart charging functions have things for allowing load balancing between chargers, just to keep what time the charging's done. So you might have a low tariff in the middle of the night, so to turn it on in the middle of the night, and also to maybe balance between chargers. So if you've got a car park, say a supermarket, and they put in 30 chargers, well, they're not expecting all 30 to be in use and charging at the same time.
Right.
So they need some form of load balancing where these chargers, they talk to each other, or they talk to some other server or another box. And by the way, we have a product that does this. Quick plug. But yeah, they talk to something, and that basically balances the load to make sure that it stays within the limit of the site. So we've just quick explanation that we've got a product called Link Rate, and it measures how much the site power is. So you got a supermarket, so it's measuring how much the entire site, supermarket, and all the chargers are using. And it also talks to all the chargers to find out how much they're using. It does simple maths to say, well, at the moment, supermarket's got all the air conditioning on and it's using loads of power, so we're going to have to halve how much current the chargers have. But if that supermarket load drops, like the shop shuts in the evening, it can increase the amount available to all the chargers. It's called dynamic load balancing. So that's another smart thing. And now there's lots of cybersecurity stuff around. Everyone's paranoid about being hacked. So that's more complexity that's gone into chargers. They will have to have, everything encrypted and certificates and et cetera, et cetera. So they're just getting sort of more and more sophisticated, more and more complicated as time goes on, basically.
So,
which is good for your business, I would gather.
Which is good for our business, yeah.
So you were talking about load balancing, and obviously we're big fans of vehicle to grid. The average person doesn't really know what vehicle to grid is, and if they watch us all the time, we talk about it. But your team did the first working project in the United Kingdom. Do you want to tell us a little bit about that?
Yeah. So in 2017, I think it was, the UK government put out effectively a competition for consortia to create vehicle to grid systems, and it's really to just move the technology forward, find out how it worked and all the rest of it. And we joined a consortium with basically a university, a local university in Birmingham called Aston University, and then two other companies who basically what we basically did was we had a large building on the university site. We had 4 vehicle to grid chargers, and our company looked after the car end of it. So we looked after the comms between these V2G chargers and effectively the building. And then another company looked after the building energy control. So they looked after basically what the building needed for heating, cooling, and all the rest of it. And then another company looked after the substation, the local substation had metering there. And basically, yeah, we created like an end-to-end system between us that the actual grid, the substation, the guys operating that could call off power from Nissan Leafs, as it was, up to 4 Nissan Leafs to offset power being used by the building. So they could, and it's obviously an experimental setup, but we got it all working. So it's basically the building, the grid could say, you know what, I want to reduce how much power this building's using. And then we'd get the Leafs discharging into these V2G chargers and reducing the power. And then you'd measure it. So, and yeah, it's the first end-to-end system that was working in the UK.
Does the UK have a time of use metering system? In other words, if I charge during midday, it might pay a few more pounds or pence or whatever, as opposed to if I charge at night or that type of thing.
Yeah, absolutely. Yeah. So we've got energy companies that offer tariffs. So for instance, the company I'm with, they have an EV tariff. So they talk to my Tesla directly and they download scheduling information to it. You could also set it up so it talks to the charger. I haven't done that because I always have an experimental charger on the wall because of the nature of my business. So it's not an identified charger in their system. But it talks to the car and it says each day, if I can plug my car in, it will say, okay, start charging at 10:30. And then it will, or 11:30 at night, it usually is. And then I pay 7p a kilowatt hour at night, whereas during the day it's about 30-something p. Just to put it into a bit of context, you can actually go next level where you can have something where you're forecasting pricing on a sort of a more dynamic basis where so that's a bit more experimental, but you could set it up so that you're actually charging any time of day. For instance, we've got a lot of wind energy in the UK, so you can have a scenario where it's very windy, loads and loads of renewable energy on the grid, and they just actually want you to use it. So you just pay very little, and then obviously the reverse is true in the middle of winter, still day, everyone's got their heating on. They don't want you to charge at that point. So yes, we've got variable rates.
How in the UK you've got a fairly diverse energy system, and there's kind of a lot of transitioning that's taking place. You've got all these, for example, all these wind turbines. I watch a lot of British television, TV series. So I see a lot. Back the first time I saw, I don't know if you remember the old series with what's his name, Fry, the comedian.
Stephen Fry,
Stephen Fry, and he had this thing called Kingdom, where he played an attorney and things like that. And one of his cars was a Reva, little gee whiz car. Of course, they got electric cars in England. Yeah. But that's when I saw the first wind turbines, and now every detective show that I watch from the England always has shots of all these wind turbines. So you've got that. Your last coal-fired plant, if I remember correctly, has gone offline.
You shut it down a few years ago.
And then you've sort of got the nuclear part is kind of like here, kind of up in the air.
Yeah, it's a bit controversial, the nuclear side of it, because the timelines. Effectively, we used to have a strong nuclear industry in the UK, and successive governments sort of didn't invest in it. All the engineers retired, and so the companies, all that industry, we lost the expertise really, and now we're reliant on countries, France and China basically, so countries that have kept active nuclear programs going to build, the big power stations. Now Rolls-Royce has got concepts of small nuclear power stations that they're rolling out. I mean, it's certainly not my area of expertise, so I know what I read about. But what we have got is a lot of wind, and we've got a lot of offshore wind, a lot of onshore wind. And when it's windy, like at the moment, you can have 50% of the energy generation. It could be as high as that. Could be from wind power.
Yeah, we have the same thing here on the Great Plains. So So Elon Musk, I understand, is trying to most of the companies are sort of like independent energy companies, and you subscribe to whichever one you think is going to give you the best deal.
Yeah, yeah.
So Elon Musk, as I understand, is trying to get into the business there, but it's not had a good reaction. What are you hearing on your end?
I have to be honest, I've not read about that actually.
Okay.
So
All right.
yeah. It's not something I know about.
Okay.
So
I
what
will
do you-
read up on it though.
Oh, okay.
So one of the big challenges with like vehicle to grid is actually having the vehicle manufacturer being okay with
Correct,
the vehicle
yeah.
being used like that.
Yeah.
What do you see that needs to change to really make bidirectional charging and vehicle to grid really work?
Yeah, so there's a few challenges on V2G. So the first challenge was that the car manufacturers were worried about the batteries, and because they were warranting batteries on mileage. So the problem they had was that, say you had Nissan Leaf and you had a 50,000 mile warranty on the battery, which I think that's all it was. I mean, I had one in 2018 for 4 years. They were worried that if somebody's using it as a V2G system, they're constantly cycling the battery, and you might do 30,000 miles, but the battery wears equivalent to 100,000. Some of the companies are still worried about that, and they have mileage limitation. They have one of my friends actually. He's looked into it, getting V2G installed at his house here, and he was looking at VW. And I think I'm right in saying that he had like 100 kilowatt hour usage limit. So effectively, you could use it as a backup, emergency backup on your house. But what you couldn't do what people want to do, which is just use it day in, day out with their PV array. So so that's the first thing, is like getting but the reality is, from the Vigilix, one of the things that we did as part of this Vigil project, this V2G project, was there were a couple of researchers at the university who studied the effect of V2G cycling on battery wear. And what they actually found, bizarrely, was that it basically not only had almost no effect, it actually could be beneficial. Positive, because what people were doing, if they left their car permanently plugged in, permanently on 100% charge, that's really bad for the batteries. If you actually leave your car sitting at 30% charge, 40%, probably 20 upwards, in that middle range, the batteries are quite happy. You know, they don't want to be really deeply discharged. They don't want to be fully charged. They want to be in that middle range. And actually, a V2G system could actually benefit you by keeping your car battery low until you need it, and then charging in the run up to you needing it, providing you have a sort of fairly predictable lifestyle. So that was, the first thing was the batteries and the manufacturers. Second thing is the grid codes. So the problem, you have to output the electricity, the waveforms from your inverter, from your car, or from the charger in a way that meets the local grid conditions. And the problem is there's loads and loads of if you look at a map of Britain, and I'm sure the States is the same, it's all chopped up with all these utility companies, all their own, and they all have their own standards. They have these grid code standards. So you've got a challenge there in terms of how do we get the grid codes downloaded to the chargers and the cars to make sure they meet standard. And then the third thing is that you've got we've got a Betamax VHS situation going on, that we've got AC V2G that, say, Renault's taking on, so where the inverter's in the car and it can work with a standard AC charger, or nearly standard, and DC, which is more like your fast chargers you've got out on the road, your DC chargers. They're more expensive. Even people bring out small DC chargers. There's still a lot more electronics in it. There's a lot more stuff, so it's more expensive. But a bunch of companies support DC vehicle to grid. So we've got a bit of a standards issue going on, and so you're sort of saying, "Oh, well, I need to design a charger that can work with AC or DC V2G. It needs to meet the grid codes. I need the car companies to stop putting limit to, firstly, to unlock it, to allow it, and then not to put some limit on it as well." So but the interesting thing, all these challenges, none of them are technical challenges. They're all regulatory challenges or economic challenges. The actual way of making V2G charger, that's solved a decade ago. It's getting the the governments and the car companies and, power companies, all these people are on board along for the party, and then we can all enjoy it.
What do you hear across the channel? The EU.
I mean, we're close, despite Brexit. I mean, we're closely tied into the EU. It's our biggest export market. Our standards are basically aligned, and yeah, I mean, effectively, there is a split though between as I said, the sort of Nissan, Renault, and the German companies. So my understanding is that the sort of German companies have gone more DC V2G, Renault's, Nissan's gone AC. South Korea's like Hyundai, Kia they've got V2L on their cars, so you can power a fridge from your car. You can actually charge one car from another car. All that stuff's great, but what V2L doesn't allow you to connect to a grid because it doesn't have that technology for locking the inverter to the grid and meeting the grid code standards. So, but it is AC V2G, so there's just this bit of a split in the market that. It like Betamax and VHS, these things are going to work themselves out.
Yeah.
But at the moment, it's just another sort of fly in the ointment to making it a mass market.
Over here we had the CSS charging standard, and all of us, but Tesla went out and built all these wonderfully reliable superchargers.
Yeah,
and, and suddenly, overnight, it seemed everybody flipped and said, we're going to get rid of the common charging standard. We're going to now go to the Tesla system. Is that what's going to happen maybe with the V2G, V2L system globally?
We're just dealing with a lot of very slow moving entities, power companies, governments, or even auto companies. It's sort of, they all work at a pretty slow pace. There is space in the market to have both systems. Fundamentally, they both can work. I see you'll get chargers that can just do both, but I think the problem is DC V2G chargers are more expensive just because there's just more stuff in them. So the nice thing about an AC one is that you're driving around with it. In theory, if the chargers are much cheaper, it's basically the similar cost to a standard EV charger, domestic EV charger. So I sort of see the AC having some advantages over the DC, but the DC got there first, so it's the older standard as such.
Right.
Well, there's always going to be a lot of different standards until one takes over. I mean, you look at like what NIO's doing in China with all the battery swap locations, right? I just don't see that because charging technology keeps getting faster and faster. At a certain point, there's no real advantage to the battery swap for a car. On the flip side, I think with tractor trailers or lorries or whatever, the battery swap makes far more sense.
Yes.
And even then, when we talk about load balancing in the grid, if you have a facility that has 500 kilowatt hour battery packs sitting there constantly being charged or sitting there waiting to be used, it could definitely be used to load balance the grid because that's a lot of storage, right?
Yeah, absolutely. So, the potential's amazing, really, for the amount of gigawatts potential virtual power plant you could have in Europe, in the US, for solving a lot of the issues. The problem with renewables, right? You can't store renewable energy like naturally. You can't store wind. You can't store the sun. In the same way, you can have a bucket with coal in. You can have a tank of oil. You can have a tank of gas, but you can't store when it's windy. So obviously, we need ways of storing all these renewables, and EVs are they're perfect. I mean, they're just a load of batteries on wheels. So the sort of if I look at the utopian view of this, is that we have the means to really decarbonize energy worldwide with the help of EVs, and the engineers all want to do it. We know how to do it, but it's just dragging everyone along with us, particularly politicians. Let's be honest, but it's just dragging along and educating. But effectively EVs could really help with grid stability. They're not they can initially seen as a problem with everyone trying to charge at the same time, but actually a lot of ways they're a solution as well. They're just a big battery on wheels. And as you rightly say, if you've got like truck stops and bus depots, I mean, buses, they don't run at night. You've got a whole load of batteries just sitting there at night, anything really. But those big batteries, it'd be really great to have them being used in a more profitable way for society.
Yeah, well, we talk about this with school buses, because school buses charge during the middle of the day between routes, and then at night,
they're just for
about 14 hours a day, they're just sitting there.
And again, it's a great time of day, isn't it? Because they're doing no school runs home. Right. They're probably still got a load of energy in them. They could be just completely discharging while everyone's getting home and making their dinner and all the rest of it, and then they can charge overnight. And when the electricity's cheap, time for the morning. So they would be school buses would be ideal for solving that lots of energy at the end of the working day problem.
Yeah. Interesting fact I learned over the weekend. Do you know which European city has the largest electric bus fleet?
Don't tell me. Let me guess. Reykjavik, is it? Or actually, I suppose that's
Moscow.
Moscow. Oh,
really?
Right, really?
1,500 electric buses.
Wow.
Yeah.
Yeah.
So I want to go back to a question. So one of our listeners, Bobby from Oasis Amps, has an app that's basically like charger sharing. So it's basically like you could share your private charger if you've got one that somebody can hook up to outside.
Charge on your drive.
And so he has this question that's on the screen. Can third-party apps pull the charger data using MQTT, webhooks, cloud, or API sync many chargers?
So if it's one of those it depends questions, isn't it? So a standard charger will talk OCPP to a cloud backend, which that's the standard language rather than MQTT. For instance, we have looked into. We actually had customers asking us to do an MQTT charger a couple of times, but they've not gone to market because the sort of de facto standards OCPP. You could, in theory, run your own OCPP server and connect your charger to that. But how you would interface that with other people, I mean, it just depends on your sort of coding skill or whatever. Because the thing about having a smart charger at home is that actually most of the reason for smart charging is more around either regulations, as in you must have a charger that can be turned off by an energy company, and certainly UK smart charging regs has connectivity requirements around it because they're concerned about everyone turning their cars on at the same time. But you could, if you don't have those sorts of restrictions and you've got a smart charger, you could get an open source OCPP server, connect it to it, and then do crazy things with it, probably. Mm-hmm. Yeah.
Appreciate you answering that. Let's see here. So I'm not really familiar with the plug-in charge standard.
Yeah.
And so there's a lack of universality of that. What do you think are the biggest obstacles to seeing that as?
Yeah, okay.
Can you explain what it is and what the
I'll explain what it is, right? So it's all about giving that sort of what you might call the Tesla charging experience to everyone in every EV. So with a Tesla, right, you drive it to a supercharger, you plug a cable in, you walk away. You don't have to get an app out, you don't have a phone out. The car has your credit card details on the Tesla account. The charger identifies whose car it is. It knows the state of charge. It charges the car. You get billed, and you just forget about it. And it works really. It's a really nice system. The problem is most cars don't have that. You turn up to a charger, you have to do some form of payment with a credit card, or you have to get an app out, and So the issue is that a traditional old-fashioned charger, and I say old-fashioned, I mean still most chargers on the market now, don't know what the state of charge of your car is. The basic language which a car talks to a charger it's very, very basic. All it knows is I'm taking this amount of current. Yes, you've got permission to use the charger, relay switching, this is how much current I want. But the charger has no idea what your car is, who owns it, how big your battery is, when it's going to finish, how full your battery is. So that gives a lot of problems. If you've got a load of chargers, you might want to say, well, I want the empty guys to charge first and all the rest of it. So all these problems have been identified. And this thing called 15118, which is better known as plug and charge, though strictly speaking, it's not the same thing, has come about. And so the idea is you'll just be able to plug in the cable and there'll be new communications over the cable to the charger that again says, oh, it's this person, it's this car, here's their details, this credit, all the authorization or payment details, and it can enable it. And you as a user, it makes it much less hassle for you to use a public. We're talking about public chargers here, really, to use a public charger. And plug-in charge is part of this 15118 standard, which is the sort of payment end of it. But you can have 15118 without the plug-in charge, just for finding out what the car is, what the state of charge is. It's a big, complicated standard designed by committee. They brought out a version of it called 15118-2, and then cars very slowly started appearing on the market supporting that. And then they went, oh no, that doesn't really support V2G. Let's do a -20 standard. Oh, and let's loads and loads of changes to it. So you can imagine from a developer point of view, it's been an absolute pain in the rear end, because we've had to, I mean, we developed our own stack for this software stack, took us a few man years. And then it's like, oh, now you need to do -20. Oh, by the way, we haven't finished writing that yet. And there aren't any vehicles on the road supporting it, So, but in the longer term, I imagine most cars will support it. It's not expensive, particularly to put it into a charger and a car. I imagine most cars will support it. And they'll be -20 probably in the longer term, because that's the newer standard. Though by then there might be -30. Let's we'll all be back to square one. But yeah, it should improve the charging experience for people and make level the playing field a bit, so we're all just able to plug a cable in and walk away. That's the idea.
So tell me what your ideal customer avatar looks like. You've got people that come to you. What do they look like?
Yeah, so they're one type of customer are people who already make EV chargers and they just haven't got enough engineers, or they just want to do a side project away from their core business. So that's one type of customer we've got. Another type is a company that is in electrical stuff anyway. So street lighting is a perfect example, but it could be commercial lighting or something where they're used to electricity, they're used to putting electrical products together, they're used to all that, they know all about that, but they don't know anything about EV chargers, and they want to have an EV charger in part of their product portfolio, because they might be getting contracts where it's like, can you put in 100 street lights and they all need to have chargers on them, and at the moment they're having to go to another company to buy those chargers. So they might say, well, actually, we won't do that. We'll actually sell the lamp and the charger. So it's that sort of company. So yeah, people who are in some sort of infrastructure, they want a charger, but they don't understand anything about them. They don't want to hire a whole engineering team. It takes a few years to get to like from conception to market. It's over sort of 2 years basically if you're designing a charger from scratch. So, we're really knocking a year off that by, really jump starting it. So the customer still needs to do the mechanical side of it. They still, and that might be burying stuff inside a lamppost, for instance, or it might be a metal box, or pillar, whatever. But they don't have to worry about all these standards and all these different competing, this might happen, that might happen. CCS, all the rest of it. We look after all of that for them.
Yeah.
Oh, go ahead, Bill.
Oh yeah, I'm just going to ask you on the subject of the street lights. Years ago, I've got a street light right out here, and it's got a little port on it, and I thought, why can't we just put a plug there, right?
Yeah.
And,
Well, that's happening.
And so I see that's happening in the UK.
Yeah.
Is there enough current? I mean, what kind of, you're operating, I think, if I'm not mistaken, 240 is the standard, if I remember.
Yeah, correct.
At 50 hertz. Over here, we're at 110 at 60 hertz or whatever. What are the issues of doing that? Of just taking a street light pole that's already there, it's got a cover. I pull the cover off and I make that a charger.
Yeah, well,
even if it's just level 1.
Yeah, just level 1.
Yeah, I mean the issues are basically, you're quite right. The cabling might not be of sufficient size. However, of course, when you're putting any of this stuff in, a lot of the cost is the groundwork. So digging holes in the street, putting the stuff in, filling the tarmac and all that. So the fact is, with a street light, you've already got all that done. You've got a cable running through a cable trough, so you can replace the cable without having to dig everything up. So that's a massive benefit. You don't want to drill holes in the lamppost. That's the other thing, because no one likes lampposts falling over. Right. So you need a way of doing it that.
Well, there's a little cover, right?
Correct. Yeah. So you need something that goes on the cover. But actually, so there are a load of chargers. There's a mixture of different streetlight chargers in London, but there are some that are inside the lamp. Which is a bit challenging because of the diameter of the pole. But what one of the customers found was that actually people weren't able, they're driving down the street, they can't see which has got a charger on because all the lampposts are the same, particularly at night. And actually having a box on the outside makes it more obvious that this is got a charger on it. Right. So even though it might not look quite as elegant, it means that the guy driving the car can tell where he's charging. But yeah, that's the other thing we've looked at in which I guess would apply in the US. So in Britain, all the cables are buried, but one of our big markets is Australia, and there they actually have overhead mains power like you've got in North America, and so they've got pole chargers there. So that's your big fat wooden pole. You've got a box sat on the outside of it. All right. Perfect, because you've got power on the pole. You've just got to drop it down. It's easy for me to say that, but effectively, it's great. You got a big fat pole. You stick a box on the outside. The only issue with it is they're not that frequent compared to street lights, so it doesn't give you necessarily loads of charging positions. But it's still a good. At the end of the day, we need a real mixture of lots of different types of charge and lots of different locations. It's not like just one magic size that fits all. So pole chargers are part of that mix.
Interestingly, we have a company here about 20 miles from us that's what they do. They are light pole manufacturers. And I thought at some point, if we could figure out how to put together a nice electronics package and go say, hey, here's something that you as a light pole manufacturer might be able to offer your customers if you're interested. But,
Yeah, well, we can do that. So give them my details.
One of the things that Bill and I were discussing a couple of days ago was that the EV industry doesn't do itself a lot of favors in that since most people figure out where the next charger is from an app on their phone, there's never any signs that identify EV chargers. It needs to be a way to, either make those, like Bobby here saying, you can paint the charging poles, make them all fluorescent orange, right. Which would be hideous, right? That'd be hideous. But
we do use. It says you use cellular communications for data. I mean, that is what these chargers have. They got cellular comms on them. Yeah.
Okay. I have played with augmented reality. Okay. I developed an app that will display if you will, it's a pole with a little rotating thing that identifies what brand the charger is. So if
Okay.
so if you had your phone, which is what nobody's got any affordable glasses at this point. But if you were driving down and you get near one of these, it's synchronous, geolocated, GPS located. As you get closer, this thing pops up in your view, whatever that view is, and shows you and guides you to where the charger is. Crazy idea. It worked, but of course, there's pieces of the technology that aren't there yet. But that could be a way to just.
You could have it in a head-up display on the car. I mean, I drove this Hyundai EV6, which had a head-up display.
I just had my phone.
Yeah.
It sounds like a Pokemon Go app.
Sort of, yeah. But I actually got it to work. I tagged a bunch of local chargers around town. I tried it on it, and it worked. So that might be an approach.
I love it.
That'd be the way, actually, if you did integrate it with Pokemon Go, that you could only capture the Pokemons where there's an EV charger.
Right.
So then the kids would all grow up learning that, the Pokemons are all where the EV chargers. They just think there's EV chargers everywhere, right?
Yeah. I like it. Yeah. I mean, it raises, this discussion. I mean, as I was saying before, a lot of the issues, they're not technical issues. Most of the issues are regulatory issues. And like one of the main regulatory issues is like parking spaces. It's like having a free parking space in front of the charger. And in particular, if you live somewhere like London where 70% of people don't have off-road parking, so they're parking in the streets. If you've got an EV, how do you guarantee yourself a space in the evening by a charger? You might get there and there's a some big SUV parked in the space. So I mean, obviously a company, technical companies like ours can't really help particularly with that necessarily, but this is it. There's so many parts of this jigsaw. A lot of them are very basic. I mean, as your chap was suggesting, like painting the lamppost a different color. Brilliant. I mean, it's like just a simple, low-cost solution. But you'll probably find that the council's got regulations about what colors the lampposts can be. Right. It's usually that's what you hit. You just, City Hall, isn't it? You talk about hitting your head against City Hall. I mean, this is basically what we all face all around the world.
Get to do the old barber shop, rotating ribbon.
Just take reflective tape and wrap reflective tape
around it.
World War II D-Day invasion style, right?
Yeah.
3 white, 3 black, right?
I mean, another thing about these lamppost chargers was they found that, like, if the top was flat, people leave things on it. They leave a can on it. So they have to make the top not flat, so people can't just leave something on top. I mean, or use it as a step to climb up the pole.
Yeah.
It's just crazy stuff like that.
Yeah.
Oh, that's funny. Well, I mean, it would be useful, like if you wanted to set your phone down while you were plugging in the charger, right?
Yeah, but then you forget and you leave your phone there. Yeah.
Well, it would happen, I'm sure.
These are all first world problems, right? First world problems.
Yeah.
That we should all be thankful for. Anything else you'd like to tell us and our audience?
Well, I mean, what's going on over there? I mean, in terms of the latest stuff, because
who knows? It changes every day. We've got a big announcement happening here in about 32 minutes.
We don't know what it's going to be about.
We don't have no idea what it's going to be about, right? It's obvious that, in fact, I came across an article, which is an interesting thing, that says what we're seeing is the beginning of a ecological Cold War that's dividing the petro states of the world, and it lists the United States, Russia, and Saudi Arabia against the green states, which of course would be essentially Europe and other of the countries that are serious about doing something to control, decarbonization. So is that what we're starting to happen, or is this just a temporary aberration until we get a new leadership in the White House, right? A lot more progressive leadership in the White House. So we're kind of, we don't know what's going on.
No, it makes it. I guess it's the uncertainty is the problem, isn't it? It just makes it very hard for people to invest. But I think the main thing is like there's been a lot of headwinds and doom and gloom in the media about EVs and all the rest of it. But the reality is people are buying them. It's making up over 20 to 30% of the car mix over here. They're on the road, and the second-hand ones last, and they get sold as well. So, we got more and more EVs, and it's gone from being something where you just hardly ever saw one. It's just like the really commonplace now. So, I think there is some hope in that consumers are sort of voting with their wallets and just getting EVs anyway, and sort of ignoring what the powers that be are telling them.
In our country, we don't see this issue come up much, but I know it's a big issue in the UK. In the UK, if you're having to use public charging, you may be paying more to drive your car than you would be if it was a gas car.
Correct. Yeah, that is an issue. Yeah, specifically in the UK, not so much on the continent in Europe, but the UK's got a real issue with the price per kilowatt hour of charge. So yeah, you're absolutely right. If you're using like the more expensive rapid chargers, you could be paying more than a low cost. The cheapest sort of small runaround petrol car, which is it's terrible. It is a problem. There's a real inequity. So I was going to say it's a real inequity between people who have off-road parking and can have their own charger and are paying literally less than a tenth of what a public charger is charging, versus somebody who doesn't have a drive and has to park in the street. And is facing these costs. So again, it's not a technical issue, but solving the problem, making it equitable for everyone, it does involve addressing that issue.
I assume that as time goes on, we're going to see, and I'm sorry, Bill, we're going to see the economics change because it's supply and demand, right? As you have more and more chargers and you have more companies competing in that charging space, you would think then there'd be enough supply that it would start driving down the price. You'd think.
Yeah, you'd hope so. If it gets, competition would be great. Yeah, to sort of drive it down. And also I think for me the other thing is that really destination chargers, AC chargers, they should be charging a lot less than a rapid charger. And they're not really at the moment because rapid chargers obviously are very expensive. They're very expensive to install. They might need a substation upgrade. They're large, so it makes sense that those are expensive. And to be honest, as an EV driver myself, I don't often use them. When I do use them, to be honest, I don't mind paying because it's just getting me somewhere.
Yeah.
But the destination chargers that are on the street, that slow chargers, are actually the equivalent of what an off-road, on a drive. Those really should be cheap. They're not expensive chargers. They're very, very cheap chargers. The investment in them is low. There's still maintenance required. There's still stuff. So absolutely, you can understand them needing, and the company's got to make a profit that's done the installation. That's all fine. But at the moment, that's I think where the problem is, that the pricing is just too high.
Okay, let me get my question in. What's the most common EV that you see on the streets in your area?
Well, the Model Y is, I think, the most popular EV in the UK. I've got a Model 3. So Tesla's still top. BYD's been late to coming to the UK. So I'd say those. I see quite a few ID3s around.
Okay.
Nissan Leafs were the most popular, but they've sort of diminished a bit. I'm hoping. I used to have one, as I said. I loved it. I'm hoping they come back again. But yeah, I'd say Tesla's probably the most popular, and then probably VW next. But I haven't seen the stats recently.
Okay.
All right. Well, we've ran over time already, so which is not unusual for Bill and I. By any stretch, we catch ourselves. We drift off into other topics all the time.
Yeah,
it's his fault.
There you go. Yeah. Well, it's just easy. There's always a lot to talk about. It's really kind of surprising. I've been doing this with Bill for about 2 years, and there's never a shortage of stuff to talk about. It's really, you'd think it's like, oh, they're just going to talk about, a Tesla or something. And it's like, no, we very rarely are actually even talking cars. It's usually talking technology and changes, and
And
we also
policy and
aviation and trains, and so
buses.
and buses. So we kind of cover the gamut of of things like that. Anyways, I'm going to go ahead and cut the stream. Stay on for just a second after it cuts.